Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 4, sequence and the series. This is our lecture number 27. In this lecture, we're going to talk about representations of functions as power function, power series. So basically, we want to see for a given function, how can I expand it into a power, I represent it into a power series here. Okay, so now let's go ahead and go to our lecture notes and let's go ahead and start it. All right, so here we said, for this ones here, for this lecture number 23, the first part of this lecture here, we talk about the representation of function as a power series. So for the whole sections, we have 3 key concepts we try to cover. So the first concept is how do I obtain a power series? Okay, expand expressions for a function by manipulating some known series here. So this is the first way, for a given function, if this function we can manipulate from some existing known series, convergent series, then we can expand that. And then the second part here is how do I take the differentiation and integration of a power series. Then the last concept is here. Then there is like if for a given function, how do I do the power series expansion? Power series expansions by the differentiation and integration. Okay, so like for the first part here, so for the first part and for this lecture series, we're going to cover these 2 topics here is how do I get a power series expressions by manipulating some known series here. And we're going to divide it into 2 videos. So the first video, we're going to talk about this one, how do I find the power series expression by manipulating known series. Then this will be our video. So this is video number 1, then this is the video number 2. See here, how do I differentiate, how do I take the derivative and the integration of some power series. Then the last one, see here, the power series expansion by differentiation in the and the integration, see here. So for this part, we're going to cover in the part 2 of the list sections here. Okay, so let's take a look at the first concepts here. The video number 1. So this is the video. How do I obtain the power series expression by manipulate some existing series? So one of the very most popular existing series we know it's good, we can find the value is the geometric series, right? So okay, so let's kind of refresh our memory. So we know it's for geometric series. Okay, so if your geometric series is like 1 plus r squared plus r cubed, if I can write this ones here is n from 0 to infinity r to the nth powers, right? So we know if the r, right? So we know if the r is less than 1, like the absolute value of the r is less than 1, then we know this is a convergent series, right? So we know the sum of this ones here. Okay, so we know the sum of this one will be what? Will be 1 over what? It's 1 over 1 minus r's here, right? So this is what we learned from the the earlier sections, right? So about the geometric series. So if r is less than 1 here, I'm sorry here, I did this is a terrible notations here. That means if I add those powers, so that means the summation n from 0 to infinity, the r the nth power, this one's here, the sum will be what? 1 over 1 minus r's here. Okay, so now now I changed the r. So for the functions here, so based on this geometric series, so if a functions here, so if I have a function f of x equal to 1 over 1 minus x here. All right, so then based on this ones here, you see the, okay, this is 1 minus x, right? So I can treat my x is what? Is my r, right? So that means I can rewrite this one is the summation what? I can rewrite this one as a summation n from 0 to infinity, x to the what? N's powers here. Okay, so in here, the one thing here we need to be very careful here. Okay, so we need to be very careful. In the algebra world, if you said f of x equal to the 1 over x, right? So we know the domain for this function is what? Domain is the whole real number except x equal to 1, correct? But in here for this ones here, because we know, if this is geometric functions, right? R, the absolute value of R has to be less than 1. So in here, so we know, so for these expressions, right? But for this expression, if I try to find this one into a power series, it's only going to work for what? The absolute value x is less than 1 because x is my r's, right? That means x is from 1 to what? 1 to, the -1. Right, so this is what we need to be careful here. So if you want to write for the 1 minus x to the expression of the power series, okay, then the x value has to be 1 to the -1 because I use geometrics here. And I know the geometrics here, right? So I know the geometrics here are, right? So this is the key things, the r has to be less than 1. The absolute value of the r has to be less than 1. So that's why in here, be careful, right? In general, if just give me a function, it's 1 over 1 minus x, I know the domain is all r except x equal to 1. But if you want to express this one into a power function, it's only going to work when the x between 1 and the -1 because of the, the r, the geometric series, the r, the absolute value of r has to be less than 1 in order to be convergence here. Okay, so now after this one, this will be pretty easy. So now let's take a look the first examples here. So let's say find the power series for the one f of x is 3, this is 1 minus ax cubed, right? So basically, so what is your x here? So this is ax cubed is your x here, correct? And so this is 1 minus, so you kind of think about this is your new x, 1 minus x here, all right? So 3 is just a constant. So this one you can write as power series to be 3 then times n from 0 to infinity. Remember, right, it's xn. So what is your x here is a x3 to the what? To the nth power, right? Remember, this is your new x's here. Okay, so now this one's here will be, so the power series will be summation n from 0 to infinity 3. A is 2 to the 3, so it's times 2 to the 3n and x to the 3n's here. All right. And okay, so be careful here. So where is the, the domain or the interval? So over the interval of the convergence is here. Remember, we are manipulate a geometric series. So I know the absolute value of the r has to less than 1. So what is the absolute value of r? My r is this ax cube, right? So this is the geometric the r, so has to be less than 1. So that's why I see here, so it's x to the cube less than 1/8. That means x is less than 1/2, that's right? Absolute value is less than 1/2. So the interval, so that means x is less than 1/2 and greater than negative 1/2. So the interval of convergence is here will be what? Negative 1/2 is 1/2. Okay, so be very careful here. In here, we do not need to check the endpoints, right? Because we don't need to check the endpoints like x equal to 1/2, x equal to negative 1/2. Why? Because we are trying to match the geometric. So we know the geometric, the convergence condition is r, the absolute value of r is less than 1. So that's why the interval of convergence here is negative 1/2 and 1/2 here. Okay, so now let's take a look at the second one here. The second example, I want to find the power series, 2x, 1, okay, 1 plus x squared. So let's see here. So this is 1 plus x squared. Let's take a look at these ones here, right? So the 1 plus x squared, be careful, I want to use this 1 minus x is equal to summation n from 0 to infinity to the xn's power, right? So this is 1 minus, so I need to 1 minus negative x squared to the 1. You see here? So this is my new what? My new x's here, right? So based on this one will be summation n from 0 to infinity, then the negative x squared to the n, correct? Okay, so now we can kind of, so this is n from 0 to infinity, negative 1 to the n, x to the what? X to the 2n. Now, for the f of x, okay, so f of x is 2x, 1 plus x squared. So it will be you times the 2x times whatever this series we just find. Okay. Okay, so if you put the 2x in, so this will be summation n from 0 to infinity. So this is negative 1n, so 2. Then this x and this x will give you what? N, 2n plus 1 here. Okay, so it will be 2n plus 1. Then the same, the interval of convergence is here. So remember, we manipulated the geometric series, right? So this is my r, new r, or x. So I know my negative x squared has to be less than 1 here. All right, so that means the x absolute value less than 1. That means x from 1 to negative 1 here. So this will be my interval of the convergences. So interval of convergence here will be -1 and 1 here. Okay. All right. So now let's take a look at the second ones here. So second one, I want to find the power series is 1/2 minus x. Oh, too bad. My formula is 1 minus x. All right, so what do we do here? We say, okay, let's change it to see I can match these terms or not. So you will say, okay, 2, I want to change it to 1 minus x, right? So I factor the 2 out. So this is 1. If you factor 2 out, what is x here? X is x over 2. Okay, so where is my r? It's this one. It's right. So this is my r. And then the 1/2 is just a constant, right? So I will just leave the constants here. Then this 1 minus x squared is geometric. So I can for n from 0 to infinity. Then xn, so what is my new r here is x over 2. Correct? All right. So that is correct. So now you can move the 1/2 in. So this is n from 0 to infinity. This is 1/2 x over 2 to the n. So the final power series will looks like what? X to the n. What is the bottom here? 2 and 2n. So it's n plus 1. Right? Okay, so the same way, what is the interval of the convergences here? So the interval of a convergence will just be, because this is my new r, right, or new x, so it's x over 2. The absolute value has to be less than 1. So that means the absolute value of x is less than 2. So x is from 2 to -2. See here, right? So this will be my interval of what? My interval of convergences is -2 to the 2. Okay. All right. So now let's take a look at the problems here. So the number 4 is here. Okay, so this one here, I want to find the power series for x over x force minus 1. Okay, so the x force minus 1 here. Let's take a look at how do I do this one. So this one's here, I need to have 1 minus something, right? So I switch the bottom, so it's 1 minus x4. So that means I change a negative sign, so I put a negative sign up here. Correct? Okay, now in here, I know the 1 minus x4 is based on the geometrics. This is my new r or new x. So you can see here. Okay, so what is this one's here? This will be the summation n from 0 to infinity x to the 4th to the what? Nth power. That's right. So this is the 4th and the nth power. And now my f of x is equal to the negative x 1 minus x fourth. That means you times the negative x n from 0 to infinity x fourth to the n. You can move the x inside. Okay, so you can move the x inside. So this is x times x4 to the n. So this will be the negative n from 0 to infinity x what 4n plus 1. Okay, so the same way we talk about the interval of convergences here. So the interval of the convergences here, what will be here? Because this is my new x's, right? So this is x4 is less than 1. You take the 4th root, so you will get the absolute value of x is less than 1. So x is from 1 to what? -1. All right, so So it's just the same way as we did for the other problems here. So here is -1 and 1, right? It will be the interval of the convergences here. Okay, so now here is a good place to stop, and then we'll come back here to continue the differentiation and the integration of a power series. All right, so looking forward to talk to you in the next video. Okay, bye.